Yes. Okay, chapter 5. Oh, that's not what I want. There we go. Chapter 5 is probably, out of all the chapters that we deal with in basic algebra, tends to be the easier of the chapters. Finally, huh? There's a couple things in it that might be more difficult than others, but in most cases, chapter 5 tends to be the easier chapter. And in chapter 5, they break 5.1 and 5.2a is all of the exponent rules. So you have all those on one sheet. That's what the sheet I just handed out to you happens to be, because this has every exponent rule that we are going to deal with in 5.1 and 5.2. So, or 5.2a. 5.2b is scientific notation, and we'll get to that next time when we get around to doing some stuff of videotaping things. But anyway, when you look at the product rule of exponents, what the product rule of exponents states is that if I have like bases, so in an exponent, you have a base, and up above you have a number, and that number is considered to be the exponent or the power. So that is the piece that gives me that extra amount in there of what I have. But my product rule of exponents states if my bases are the same, I can take my exponents and just add those together. Now the reason that works is if I had a to the second power times a to the third power, that's the same as saying I have a times a, because the exponent tells me how many times I want to see the base. So that 2 tells me I want to see a twice. This 3 tells me I want to see a 3 times. And so what do I really have? Well, I have a squared times a cubed, or I have a grouping of 5 a's. Okay? So that means every time I've got like bases, I can take my exponents and add them together. My intermediate algebra class last week, we added fractional exponents, because that's the part we were dealing with at that. But the rules are still exactly the same. So you will see this come back at a later date if you go on and take intermediate algebra. So it's again, the bases are the same, I can add my exponents. So x to the 5th times x to the 6th as my example. What will my answer be? X to the 11th. Because I just simply add them together. So 5 plus 6 ends up being 11, and so I get my 11 for my answer to that one. So that's what comes out of that. So I have my value in there that happens to be. So when I get these two bases the same, I just add my exponents and come up with them. Now, if they were to give you ones like x to the 5th, y to the 5th, x to the 3rd, y to the 7th, in that one I have a whole grouping of different things, but as long as I look and I notice that my x's are the same, I can add my exponents. So 5 plus 3, x to the 8th,
times
y to the, what was it?
12.
To the 12th. And that's my answer. Okay? So you're looking for like bases in there. So if you had this one, for instance, x to the 3rd, y to the 5th, z to the 5th, x to the 4th, what would my answer be? Yeah? And z to the 5th. Perfect. I can't put y and z together because they're different bases. So they're as different as night and day, so I can't combine those together at all. And so therefore, that ends up being my solution to that one. So you got that, guys got that one down, you think?
Yep.
Just add them together, see what you come up with for those. And so that's that piece. The next one is the power of a product rule. And a power of a product rule means that if I do not have like bases, notice A and B are different, but it's raised to a power on the outside, that means I can use my distribution rules that say I can distribute that exponent by the exponents. So if I had a squared b raised to the third power, this would mean I could take 3 times 2 and end up with a to the 6th. 3 times, what's on b? If there's no exponent, there's a, what there? There's a 1, yep. So 3 times 1 is b to the third power, and so that would become my answer. The reason this happens is because this 3 tells me I want to see a squared b 3 times. So if I want to see it 3 times in there, that means I can go back and use my previous rule that says add all my like bases together. 2 plus 2 plus 2 is 6. 1 plus 1 plus 1 for my b's is 3. And so it kind of gives me a shortcut where I don't have to write it out and see it in longhand, and I can just shorten that. So the example is x to the third, y to the second, and all of that inside of that quantity there is cubed. So what would my answer be? X to the 9th, y to the 6th.
So you just basically distribute entire.
Yep, you distribute and you multiply with that one. So it's just kind of giving that exponent on the outside to everybody that's on the inside. So some more examples of that one might be x to the 5th, y to the 3rd, z, all raised to the 2nd. What would I get with that one?
X
To the 10th, y to the 6th, yes, and z to the 2nd. Yeah. So all I have done is multiplied each of my exponents, and the z had a 1 on it, by 2 to get my answer out of that. Okay? So that's what happens to that one. Okay. So that's those 2 rules, and they're kind of the same because I've got some combining of stuff to do. Next one is power of a quotient rule. Now these rules may not be in the same order as Hawks puts them, but they are the exact same rules that are needed in that section 5.1 and 5.2a. So they are the ones that you'd end up working out in there. So in the next one, power of a quotient. Quotient means it's a division. Because I have opposite bases, notice a and b are different, I can't end up combining them at all, but I can give a to the mth and b to the mth, so basically it's that same kind of distribution that I've had before. So if I had a to the 5th over b to the 2nd raised to the 3rd on the outside, what would I get?
3 times 5 would be a to the 15. Over b to the 6th.
Yep.
And then you minus.
No.
Not that far yet.
We can't. Well, we can't do anything with these because the bases are different. A and B aren't the same.
But if they were the same.
Then we'll do some more with it. The next rule is that one. But right now we can't do anything with that one.
Right.
And the reason again this works is because this 3 said I want to see a to the 5th over b to the 2nd 3 times. And when I see it 3 times, it's 5 plus 5 plus 5, because I can add like bases. And the b is the same thing, 2 plus 2 plus 2, because they're all the same. But it's that shortcut that gets me through it. What about this one? The example that's there. X to the, nope, x to the 6. It's a 2. You might not have seen it as a 2. And y to the 8. Yep. Okay, so be real careful with that part. So then another example might be a to the 5th, b to the 2nd, all over c to the 2nd, raised to the 4th. What would that one be?
A to the 20th. B to the 8th.
Yep.
Over c
to the 8th. Yep, and that would be my conclusion with that
you
one.
couldn't go any further with those because the
Nope,
bases.
can't do anything different with it because it is what you see. Okay? Yep. So that is what it looks like, so therefore I can't do anything else with it. So that would be my answer to it. Okay? Continuing with my rules. The quotient rule, quotient again meaning divide for exponents. But in this quotient rule, as opposed to the power of a quotient, power of the quotient means it's raised to some power, but it's got a division in it. Quotient rule means that I have like bases with letters on top. This should be an N down here. It's showing up as an M. A to the mth over A to the nth, but in this case I subtract the two. So if I had A to the fourth over A to the second, what would my answer be?
It would be A to the second.
Yep, A to the second, because 4 minus 2 gives me an A to the second power, right?
Okay, now this might be a little bit off topic, but what if we were dealing with like numbers instead of letters?
Yep, we'll get into numbers. I wanted to get your rules down, then we'll talk about numbers.
Okay.
But we won't get into numbers. Yeah. So it's not really off topic. You're right on the dot. But it's just that we're going to get the rules down with letters first, because it makes it a little easier because you don't have to think about numbers. You got to multiply all together and so forth. Now the reason this works is because the top means I have A times A times A times A all over A times A. Now what do we know about that? When I have the same in the bottom and the same in the top, they cancel out. And when I have another one the same and another one in the bottom the same, when they cancel, they all cancel to ones. And notice I'm just left with A squared, and that shortens up what I have to have with this. Okay, so that's why we put those together. So what does this one mean? X to the 7th over X to the 3rd. What will that give me?
X to the 4th.
Yep, X to the 4th. Okay, more examples of those. X to the 5th, Y to the 2nd, all over X to the 2nd, Y. What will my answer be? X to the 3rd.
Y.
And a Y. We okay with that?
Yes.
Okay. Because 5 take away 2 is 3. 2 take away 1 is 1, so I get that for my answer. The thing, though, that happens with these sometimes is the bottom number might be bigger than the top number. And when that happens, if this is bigger than this, I subtract in the bottom instead of subtracting in the top.
So the X would, it would be X on the bottom.
Yes. X would be on the bottom.
It would be 1.
What would be on top?
X. Oh, Y 2.
Yeah. What'd you have, Amy? You have a question?
No.
You sure?
Yeah.
You were saying something over there.
No, never.
Okay.
So, what if we had something like this, but it's still...
Oh, if you have, here's the example that came up here, x squared y cubed all over y x cubed. So I'm still going through and trying to find things that match, right? So I'm still looking for x's. X squared, x cubed. What will I be left with?
Should be X on the bottom.
Yep. And what's on top? Then I put my y's together, so I get y squared. Okay?
Okay, so you still can do that even though they're not in order.
Yeah, you're still, all you're doing is you're hunting through here to find things that match.
Okay.
That's your goal, is find stuff that matches. Yep. And once you find out that they match each other, then you can just stick them together. Yeah. So what about this one? I better start a new sheet here.
The hard one.
Kind of getting messy there. What if you had x to the 5th, y to the 7th, z, all over x to the 8th, y to the 3rd, z to the 5th. That hard enough for you?
3rd on the bottom.
Okay. X to the 3rd down there.
Y to the 4th on top.
Mm-hmm.
And Z to the 4th on the bottom.
Perfect.
Yeah.
Mm-hmm. Good deal. Yeah. Okay. So you're getting those combined and your combinations in there. Okay. Yep. Okay. All right with these, you think? Okay. Now, if everything cancels out on top, what do I have on top? This is going to give me an x to the 3rd, right? This is going to give me a y, but what's on top? A 1. Don't forget it, okay? If you just type this into Hawks, it's going to say, nope, not the right answer, okay?
There's no plus on how the other.
Right.
know that.
You do know that, huh? Good deal. Okay. And then they might give you something like this. xy squared all over z times x to the third, z to the fourth, all over y to the second. Now, when you've got combinations like that, it's putting all of your different rules together, because what do we got to do?
So do you add them?
Yep, this and x's are on top, so they get added. So 1 plus 3 is x to the fourth. Y squared and a y squared, what happens? They're gone. Yep, they're gone. And then I'm left with z to the fourth and a z. Where's it at? On the top. Yep. And that becomes your answer. Okay.
Oh, wow.
So
All right.
still, you just go through.
You're looking for like bases. That's your goal. And when you look for like bases, then you got to figure out where are they. These were both on the top.
Oh, the y's
Okay.
cancel because
The y's, one was on top and one was on the bottom. Okay. Z's, one's on top and one's on the bottom, so I've got subtraction taking place there. So you just determine with all the different rules that you have of what happens to them. Okay. And another one of tossing the rules together. How about this one? X to the third, y to the second, over x squared, y to the fifth, raised to the second outside.
Okay, so you distribute the 2 into
But before you distribute your 2, you want to look in there and see if you can do anything. Can you do anything inside of it first?
Okay. So you want to solve the inside first before you distribute.
Uh-huh. No, y to the 6, because you're multiplying. Yeah. Be careful because you're multiplying in there, so you want to make sure that you get that multiplication going with those. So be careful and make sure you do
Now,
those.
could you distribute before you?
Yeah, you could have distributed before and you get the exact same answer, but it makes it a lot more work. Notice here I only have to distribute twice.
Yeah.
Here I got to distribute 4 times.
Got it.
Okay? But if you distributed here, you get x to the 6th, y to the 4th, all over x to the 4th, y to the 10th. But notice, x to the 6th and x to the 4th gives you x squared. Y to the 4th and y to the 10th gives you y to the 6th. So it still works.
Yeah, but
It's just, this is a little easier if you get rid of stuff in there. Okay? All right. Back to our rules, or our properties in here. Zero exponent. What this means is if you have a 0 on anything, I don't care what the base is, and you got a 0 power on it, it's equal to 1. Okay? And why does that happen? Well, that happens because if you take a look at a to the second over a to the second, what would we say that's equal to? Well, if we extended it out, it's a times a over a times a, and when our a's cancel, what happens? They all become 1s, so I get 1, right? You okay with that part? They all cancel? But if I go back and use my quotient rule that says my bases match, 2 minus 2, what's 2 minus 2 is 0. So a to the 0 power is equal to 1. So what's x to the 0 power?
I'm so confused right now. You said 2 minus 2 equals 4.
Did I?
You said 2 times 2.
Oh, she had 2 times 2. Oh, no. We're subtracting in there. It's a subtraction because it's 2 minus 2.
I thought you said 2 minus 2.
Yeah, but it will end up being 1. So, x to the 0 power
1.
is 1. Now, the other thing that's to a 0 power is if you had x to the 5th, y to the 7th, z to the 5th, all raised to the 0 power. That's also equal to
Just the same 1?
1. Because if you distribute it, 0 times 5 is 0. 0 times 7, 0. 0 times 5, 0. So you have x to the 0, y to the 0, z to the 0, and each one of them represents 1, so your answer is 1. So if it's got a 0 power outside of it, it's going to be equal to 1. Then these show up in 5.2a. For sure, I know these are in 5.2a because of the negative exponents, and negative exponents move. So all negative exponents move. So they are in one spot, but they move to a different spot. If it's a negative and it's in the top, it moves to the bottom. If it's a negative in the bottom, it moves to the top. So if I had my example of x to the negative 4th, it's going to become x to the positive 4th power. Again, they move. They go from upstairs to the basement. Okay? These guys move to the basement, these guys move to the upstairs. But they change sign.
So it's 1 over 4 then?
1 over x to the 4th. Yep.
I need more.
Yep. This one down here, the second example, is if it's in the denominator, it moves to the top. X squared.
Y squared.
Yep. And no denominator at all, because they moved. They switched places.
So if it's a negative exponent, you just simply move it to the top.
From where it is.
Where it is.
Wherever it is
top,
goes to
make
the
it
opposite place. Yep.
And that's how it's
Yeah. So more examples of those guys. If I had x to the negative 2nd, y to the negative 3rd, z to the 4th, what would I end up with? Oops, better move it down a little.
Z to the 4th on top.
Yep.
X squared y cubed.
On the bottom, right? Yep, that's your answer. Can't do anything else with it. They switch locations. If you look at a number raised to a negative exponent, if I look at this and I put it on my calculator, you guys got your calculators handy? Got them somewhere? If I put that on my calculator, I don't know if I have mine. It's down in my office. Great spot for it. It'll give you a decimal number, right?
Yeah.
So if I put 2 caret negative 3, I get, what was it?
0.125.
Okay, 0.125, right? Now the reason that happens is because if I move this, it becomes 2 to the 3rd power on the bottom. And what's 2 to the 3rd power? 2 to the 3rd power is 2 times 2 is 4, times 2 is 8. And if I were to divide 1 divided by 8, I will get 0.125. Bless you.
Okay,
Because
so
that will be my answer. So what it does numerically is it makes things into fractions. Okay? Because it moves it to the denominator, it becomes a fractional value. And so that's what negative exponents do. They're our way of working with fractions.
if we were to try and solve negative exponent, we would have to use the math button to get the fraction for our answer.
Yes, you could if you were going to ask to do that, usually it'll ask you for the decimal.
Decimal, okay.
Yep. But in some cases it will end up switching it around with those. But that's kind of, all of these are the rules that you need for that very first 2 sections of Chapter 5. And in most cases, this is probably one of the roughest parts outside of maybe division when we get to that. But this is probably the toughest part of the whole chapter, is just getting these rules down and knowing which one's which. And you got them all on one sheet, so that's a plus for you. Okay, so let's go through some examples from our sections now and see if we
I
can
got one for you.
pull some stuff together. What do you got for me, Amy?
Alright, there's 2 sets of parentheses. First parenthesis, 9x cubed y. Second set is 9x to the 0 power y to the 4th.
All right. Like so? Okay. Because we haven't talked about numbers in here yet. We've talked about what happens with our exponents. But our numbers are numbers, so if these two are back to back inside of parentheses, what does it mean that I need to do to those 9s?
Multiply?
Yep. 9 times 9 is,
81.
yep, x to the third plus an x to the 0, so I'm multiplying, so I get x to the third. Y to the first and a y to the fourth.
Y to the fourth.
Y to the fifth.
Fourth.
Fifth.
I thought you were multiplying.
Numbers. Numerically I multiply, but I am multiplying. But remember, when we multiply and our bases are the same, we add exponents.
So even though you're basically doing the distributive property, you're adding.
Because my bases match, my x's and my y's match, so I am adding exponents. So 3 plus 0 is 3. 1 plus 4 is 5. Okay? So yeah, but with numbers out in front, that's the piece you gotta work on to get those. So numbers kind of change it up a little bit and add some things. What about this one? 15x to the 4th all over 3x to the 7th. What will that one be? And again, because I got numbers, I need to work with those. So 15 divided by 3 is 5. Okay. X to the 4th and x to the 7th.
X to the third, 5x to the third. Or
No. Whoa. Wouldn't it be on the bottom though?
Yep.
X to the third on the bottom.
Yep.
okay, wait. So why don't you have a 15 and a 3 on the bottom?
15 and 3 are just doing a division. That's just straight division. 15 divided by 3 is 5. But when I get my exponents in there, I have to look at those because my bases match. My
Okay,
x's are the same.
Let's say this.
So I gotta subtract them.
You have 15x to the 7th over 3x to the 4th. What would that be?
Well, still, it's 15 divided by 3
Okay.
is 5. This time, it's bigger exponent on the top than on the bottom. So 7 minus 4
So it'd be 5x to the third.
on top. Because 7's bigger than 4.
Okay, what would be on bottom?
No, nothing. You can put a 1 there if you want, but Hawks isn't going to like that. So you wouldn't have anything. Because this cancels out. Remember, it's 15 over 3. And on the top, it's x times x times x times x. 1, 2, 3, 4, 5, 6, 7 x's all over x times x times x times x. And when these cancel, you're left with, whoops, I think I canceled one too many, didn't I? I did. You're left with 3 x's, the 15 and the 3 cancel.
And it becomes whole.
So I have 5x to the third on top. If you write it out and do it the long way.
Okay, I understand.
You understand now?
Yeah. I
Okay. But it's just getting those exponents all in the right locations with those. How about this one? 2 to the negative 4th power, x to the negative 2nd, y to the 3rd, all over 2 to the 2nd, x to the 5th, y to the negative 4th. What has to happen with this one?
Oh.
Okay. So 2 divided by
So we got to move everybody that gets moved. So who moves? Get rid of all of your negative exponents first. So it's 2 to the 4th goes to the bottom.
And then x to the 2nd
Goes where?
on the bottom.
Y to the 3rd?
stays there, but you want to move
The
the
y
y
to the
forth
negative
also.
4, yeah. Okay.
Does x to the 5th move?
No.
No. Does 2 to the 2nd move?
No.
So then combine your stuff together. So what comes out of all this? Y to the 3rd, y to the 4th are the same, so I can add them. So I get y to the 7th. 2 to the 4th, 2 to the 2nd are the same because the 2's are the same for bases. So I get 2 to the 6th.
Why don't you multiply the 2? Oh, I guess because it's all added.
X to the 2nd, x to the 5th is x to the 7th. And the last thing that they probably say is multiply this out. So what's 2 times 2 times 2 times 2 times 2 times 2? 2 to the 6, so on your calculator put 2,
64.
caret, key 6, and you get 64 x to the 7th, and that's your answer for the bottom. Now I gotta rewrite this. On the bottom I have 64 x to the 7th and y to the 7th on top. And that's what I would end up getting for that one. So you gotta move all your negative exponents first. Don't leave them where they are.
Like when it's like a number and like okay, like -3 and parentheses and 3. I keep getting my negatives messed up.
Raised to the third?
Huh?
-3 raised to the
Yeah.
third? Okay. Now, if you're multiplying this thing out, remember it's inside of parentheses, meaning the base is a -3. So that means I have a -3
it's gonna be
times a
1
-3
over-
times a -3.
Oh, no, never mind.
The only things that move are negative exponents, not negative bases. Negative bases do not move. So negative bases do not move. So the base won't move, it's the exponents. But negative exponents move. So they're going to change places whenever you get a negative exponent. So they're going to
So you're
get
gonna
out of
go
where they're at.
from 7. Okay, so if you had like a negative, say it was 3, -3, it would be 1 over x to the 3rd.
1 over 3 to the 3rd. Because your base is 3. This exponent meant I moved this whole thing to the bottom.
Oh, okay.
1 divided by 3 is 3.
So I get 1 over 27 if I multiply it out. 3 times 3 is 9, times 3 is 27. So I get 1 over 27 for your
Your
answer.
complete answer?
That's my complete answer. Because all I did, this was to the negative exponent, so it moved. Then I cubed it. 3 cubed is 27.
I gotta make sure I move my negative exponent.
Yeah. Always, whenever you do with negative exponents, move them before you do anything else with them. Don't leave them sitting where they happen to be, because you'll definitely get them in the wrong location. How about this one? 10 to the -8 over 10 to the -2nd.
So it'd be 10 to the 2nd over 10 to the 8th.
Because they moved. So what's my final answer?
10 to the 2nd is 100.
So if it's, well,
So what would be my final answer?
so a negative
1,000.
1 over 10 to the 6th. Because 2 from 8 is 6. Or if you have a base 10 and it's raised to an exponent, all you need to do is put the number of the number the exponent is, put that many zeros after 1.
Alright, I'm not getting this, I don't think.
What aren't you?
I put it in the simplest form as saying 4 to the -1. So all you would do is just 1 over 4 to the
First power.
to the first
Or
power.
1 over 4.
So okay, they don't want me to put the 1 there. They
No.
just want me to put 1
Yes.
there.
They will not accept any negative exponents. Oh, they don't want a 1 there. Oh, this one up here? If the number is small, like if you ended up with 2 to the 56 power over 1, they will like this, okay? But if you can multiply it out, they usually want you to multiply it out. This one's probably large enough that you wouldn't have to multiply it out and can put 1 over 10 to the 6th. But some of them, they're going to come back and say it's not simplified all the way. So when you do your practice, that's where you'll find out. Yeah. Yep. In your practice is where you'll start figuring out some of those of what they're asking you to do with those.
Marcel?
Yes.
I got one for you.
Okay.
I think I know the answer, but I want to make sure it's right.
Okay.
4x to the 0 power minus 3y to the 0. Would that just leave you with 1?
Nope.
No.
It leaves you with 1 for anything that's got the exponent on it. Exponents can only apply to the thing next to them. So this really is 4 times 1 minus 3 times 1. Because this is all that the 0 power is on. Okay? If they would have had 4x to the 0 power minus 3y to the 0 power with parentheses, then this whole thing would have been 1 and this whole thing would have been 1, so then it would have been 0. But because it's only on the variable that's here, it's only those pieces. Okay?
So then what would that be?
So this answer? 4 times 1 is 4 minus, yep.
That's what it said.
Oh, did you? Okay.
That's
Did you do
not-
that to it though? Did you do that to it?
Oh, wait a minute, that's what.
Okay, but did you do that to it?
No, I just basically like canceled out the, because it's x to 0, y to 0, so I basically just canceled out the x and y, because they're 0.
Okay, so then you did do 4 minus 3.
Yeah.
Okay, then if you did 4 minus 3, then you're okay. Yeah. Okay. Yep. Sorry about that. Get you back on track with what you got. How about this one? 3a to the 5th b all over a to the 0 b to the 2nd raised to the 2nd. What about that one?
You're making it.
Can you wait just a second? Let me catch up.
Write it down first, huh?
Yeah, let me write her down, please. Alright, okay,
So,
we're ready. Wow.
do you do 3 times 2?
Well, first I'd look at what's inside of here and get rid of some stuff if I can. What happens inside? Can't do anything with 3, right?
So 3 stays.
What about my a's? A to the 5th, a to the 0.
A to the 5th.
Mm-hmm. B to the 1st and b to the 2nd.
Over B to the
Just B.
first.
Yeah.
Yeah.
Then square everything. So then this 3 has a 1 on it, just like any other number or any other letter. 2 times 1 is 2. So I have 3 squared. 2 times 5 is 10. Yep.
And then B squared.
Mm-hmm. But am I done?
No,
Now you got
What's 3 squared?
9. 3? Yeah. 9, 8, 10. 30 squared.
Perfect. Now I'm done.
Alright, I got a good one.
Okay, what do you got? Let me get a sheet here. What'd you have?
It's 2a cubed, and this is parentheses.
Inside of parentheses, that piece?
B, oh, I was done.
Oh. 2a cubed b.
B minus to the negative 1 exponent, I guess.
Yeah.
How would you say to the
Negative 1. Mm-hmm.
Alright, and then, that's the parentheses in that one, and then times parentheses, 5a to the 5th, b cubed.
Okay. What do I gotta do? Multiply my numbers. So 2 times 5 is 10. A to the 3rd, a to the 5th?
So is it 3 minus the 5?
No. They're both on the top, so there's no subtraction. To the 8. B to the negative 1st and b to the cube.
Well, wouldn't that put 2?
Then put B on the
Bottom, wouldn't it?
This b would go to the bottom, but because it's on top, a negative 1 plus 3, you're just going to add your exponent.
I'm so confused. How come? Because those are multiplying, aren't they?
Mm-hmm.
So how come your exponents aren't multiplying?
Because when you are multiplying this way, you're only looking at what you are given.
So it's all on top.
Because it's expanding it out. You're not multiplying based on distribution. It's a distribution. But when you multiply, you're only looking at how many A's I happen to have.
Right.
Numbers multiply. I've got 1, 2, 3 plus 5. I got 8 A's. Okay. And then this B and this B cancel, so I get my B squared. Okay. Yeah. And again, when you do this, we've kind of taken 5.1 and 5.2a and kind of put them all together. it will be separated out when you do your homework, okay? It's just that all of the rules are in one. So if you do 5.1a, or 5.1, you'll practice some of the rules. Then when you jump into 5.2a, you will end up getting more of the complicated stuff in there.
Now I'm
Okay.
confused on the negative number, because now when I got a
Okay, if you have something like this, 2 to the third, m to the third, n, all over n squared, raised to the negative second outside, what happens to this thing? Can I put anything together inside? 2 to the third, I can't put anything with it. What about my m cubed? Anything go with it? Anything go with m cubed? Nope. N on top and an n squared in the bottom?
And on top cancels and you'll have that on bottom.
Yep. But it's to the negative second outside, so that means everything gets a negative 2. So I have 2,
To the negative 6.
6,
N to the negative 6. N to the negative 2.
okay. So then what happens?
Now you flip everything. N to the second goes on top. 2 to the 6 and n to the 6 goes on bottom.
Yep.
Boom.
So they flip. But again, you're not going to get to this. Also, if it's raised to a negative exponent to a power, you can automatically flip it
I just turn it to a
and make the exponent positive. So if you flip it, you can make the exponent positive on that one, and you'll get the right answers. Okay. All right.
We're not. I'm not.